Hi guys, in this video I cover strings in C, also named C strings or C-style strings. I first go over the declaration, I talk about the null terminator, and I demonstrate how to access individual characters in a string. I'll start out by showing 3 different ways of how we can create a C string. Now with the first declaration, you see that a C string is really a character array. The element type is char, and here the array is defined of size 20. This is initialized with a string literal that is defined in double quotes, and inside double quotes there's a sequence of characters. Now it's very important when you declare a C string that the size is sufficient to accommodate all the characters. So in this case I have 1, 2, 3, 4, 5 characters. So the minimum size would be 5 plus 1. Strings always have a special character that marks the end of the string. It is called the null terminator. I cover that in more detail in just a moment. Now let me show you another way how we can declare a C string. We know that an array is a constant pointer to the very first element. So string 1 points to the age here. This is the first element, the first character in the array. So I can also declare a character pointer. I name this string 2, and I initialize this one to hello. This is also a valid string. Now another way to declare a string is using an array. I name this string 3. I again use 20. In this case, I initialize it to an array. I use open close braces, and inside I define the individual characters. H, E, 2 L's, and O. Now this would just be a character array. What makes it a string is the null terminator. And the null terminator is defined as backslash and 0. So backslash 0 is the null terminator. And what this does is it marks the end of a string. Now next I want to output these 3 strings. So the first one is string 1, and then I output string 2 and string 3. So here you can see I always use %s for the string and then a \n for a new line break. And this outputs hi, C, hello, and hello. Now I could also use less than 20. For example, I could use 10 and everything works the same. What's important that the size that I use here is at least the number of characters plus 1. The plus 1 is the null terminator. So in this case, I have 1, 2, 3, 4, 5 characters plus the null terminator. So the minimum size that I should use here is 6. Now I could also leave as 10. I will use more memory because there's additional memory allocated for this array that is not used. And for example, if I were to add additional characters after the null terminator, such as an exclamation mark, when I run this, the exclamation mark doesn't show. This is the way the printf function works. It iterates over the characters of the array, so H, E, L, and it checks each character if it is the null terminator. So L, O, eventually it encounters the null terminator and then it stops. Now, I could also have potentially more than one null terminator. So if I were to copy this here, you can see a null terminator here and a null terminator here. What happens if I run this program? What you notice is that it only prints out HE because it encountered H, E, and the null terminator, and then it stopped. It didn't bother checking the remaining string. Now with that, let's check how we can access individual characters. We can use array syntax. I use printf %c for character, then a line break, and I access the very first string at index 0. Remember that just like arrays, strings are 0 based. 0 means it is the capital H, the very first character. I output another character. This will be the second character in the string at string of index 1. When I run this, this will output now H and I. Now I can also use pointer syntax. This I use printf again, %c\n, and then I use the dereference operator, string1 plus 2. Plus 2 because I just accessed at index 1, so I want to access the next element in the array, the next character in the array. And remember from characters that the array is actually a pointer. That means it stores the address. So if you imagine every character as a house, we have the address of the very first house, capital H, and now we want to get 2 houses further. So we have the address plus 2. This gives us the address of 2 houses further. This would be the space. And then the dereference operator means go to that address. So we go there, we read this character, and we output it. Next, I output another character. In this case, it will be string1 plus 3. That means 3 characters further than the first one. So 1, 2, 3. This will be the capital C. Then I use the dereference operator to go there and read that value and output it to the console. When running this program, you can see I have H and I using array syntax, and space and C using pointer syntax. Both of them work fine. And all this works because strings are really just a character array with the additional null terminator that marks the end of the string. I hope you enjoyed this video. Thank you for watching.